Distinguished President Dan, dear colleagues, ladies and gentlemen, good morning. Welcome to this session. Today's topic of my presentation is from natural resources monitoring to SDGs measuring. This is a perspective of China. There are three paths in my presentation. First, what are SDGs? I believe that we all know SDGs. The SDGs was established as a universal call to action to end poverty, protect the planet, and ensure that all people enjoy peace and prosperity. Last year, the UN published the Midpoint Assessment Report. The Secretary General goodly said, halfway to the deadline for the 2030 Agenda, the SDG Progress Report shows we are leaving more than half the world behind. Progress on more than 50% of targets of the SDGs is weak and insufficient. On 13%, it has stalled or gone into reverse. So the Secretary General called for actions from government, societies, organizations, and individuals. If we don't act immediately, the 2030 Agenda could not become reality. We know data and technologies are crucial in measuring the SDGs. From the red picture, we can see the serious situation of insufficient data. The significant challenge lies in the timeliness of data. We can see with less than 13% of the latest available data is from 2020 and 2023, where over half of the latest data comes from 2 years ago, 4 years ago. But meanwhile, we are glad to see the data demand for the 2030 Agenda has unleashed innovation. For example, Colombia used a satellite image to monitor SDG indicators, such as all-season road accessibility, while traditional data sources failed to measure properly. And another example is from Bangladesh. Use the integrated multiple data sources to monitor the SDGs. How did China act to implement the 2030 Agenda? In September 2016, Chinese government first issued China's progress report. After that, China released 4 editions report on every 2 years. As well, in 2017, the China Center for International Economic Exchanges improved the existing SDG system and released the China SDGs system. It not only includes 3 themes in the UN indicators, economic, social, and environment, but also as indicators highly related to natural resources environment. How could geospatial information data and technologies be used to measure SDGs? I initiated a pilot project with Melbourne University, Professor Abbas, just President Dan mentioned, to calculate some indicators in China based on our natural resources monitoring data and technologies. Then 10 indicators of SDG 9, 11, 13, and 50 are calculated to evaluate the progress mostly in China. The indicators include 4 UN SDG indicators and 6 indicators development by ourselves related to the natural resources monitoring. Here are some results we have done. The first one is indicator SDG 911. It's the proportion of the rural population who live within 2 kilometers of all season roads. The indicator means whether or not the rural population has good accessibility of road infrastructure. The index of China, we can see, exceeded 99%, almost 100%. But the World Bank gave another result, maybe is about 17%. I think it may be very severely underestimated. But if in district or country units, we can see the index ranges from 15% to 100% differently. The second indicator is SDG 1121. The proportion of population that has convenient access to public transport. We use the Gini coefficient to evaluate the progress. We can see the Gini coefficient shows that extremely imbalance exists in worldwide scale. The development countries are 1.6 times more numerous than developing countries, while European cities are about 3.3 times larger than Africa cities. In order to know the spatial differences within a city, we developed a model to calculate the indicator using mobile phone data to obtain the actual population. Here is an example of Xi'an city. The gray color means better condition, and the red color means poor condition. The third indicator is SDG 11.3.1, the ratio of land use rate to population growth rate. The average in China was about 2.5 from 2015 to 2020, which is higher than the optimal value of 1. So it indicates that the efficiency of use urban land in China is not good. The fourth indicator is SDG 11.5.5. It's 5 minutes coverage rate of fire risk score in cities of China. The rate in China was about 17% in 2022 and increased 2% from 2021 to 2022. The fire rescue capabilities in China was good and continuously improving. From the result, we can see more than 30 cities in China has a high rate of over 90%, including the large cities such as Beijing, Shanghai, Xi'an, etc. And the indexes in district or county units in China ranges from 20% to 99%. The fifth indicator is SDG 11.6.2. It is the annual mean levels of PM 2.5 in US cities weighted by population. The population exposure to PM 2.5 in China has significantly decreased since 2014. In 2020, it has been downgraded to the World Health Organization's first level temporary goal in a number of cities. This benefits from the action plan for prevention and control of air pollution issued by Chinese government in 2013. The sixth indicator is SDG 11.7. It is gray land rate and 5 minutes walkability of gray space in China. The average gray land rate and the 5 minutes walkability of gray space in China was about 20% and 40% in 2022, respectively. The gray land rate increased about 1% 1 year. If at this speed, it can be basically achieve the goal of 2035 set by Chinese government. Now more than 20 cities in China have already reached the goal. I remember there was a UN report about worldwide gray land increasing. It said that China contributed more than 40% gray land increasing in the worldwide. The seventh indicator is SDG 11.7. It's 50 minutes community life cycle rate in China. It indicates the accessibility of life infrastructure. The average 50-minute coverage rate in China was about 27% in 2022, and increased about 2% 1 year. The highest accessible infrastructure is of fire rescue, and the lowest coverage rate is of elderly care facilities. More than 40% in China has a rate of over 14%. The eighth indicator is of residence balance. It shows the status of average commuting distance from home to office. From 2020 to 2022, the average commuting distance in most large cities in China has gradually increased. The average proportion of commuting within 45 minutes in major cities is about 80%. What is interesting, although the commuting distance increased, the average commuting time in many larger cities, such as Shanghai, Shenzhen, and Hangzhou, decreased. This indicates the enhanced convenience of transportation infrastructure. The ninth indicator is of grant subsidence. We calculated the nationwide grant subsidies from 2012 to 2023, generating the annual maps of the subsidies rate. Here is the map of 2022 version. The grant subsidies occurred mainly because of groundwater drawing, mineral exploring, and so on. We developed the map use SAR satellite data. The last indicator is of regional ecological conditions. China actively participates in global ecological environment and climate governance, contributing Chinese wisdom and strengthening to the implementation of the 2030 agenda. Based on the ecological environment monitoring, we designed an index to evaluate the regional ecological conditions in Yangtze River Delta. The index is organized into 5 dimensions and includes 11 indicators. The index was released jointly by Xinhua News Agency and my academy last year. The result shows the ecological environment is generally stable and improving in Yangtze River Delta from 2016 to 2021. If we divide the index into 4 levels, we can see 6 cities in level 1 and 12 cities in level 2, 60 cities in level 3, and 7 cities in level 4. We also take Deqing County, the UN center located in Deqing County. We take Deqing County as a sample to evaluate the coordination of its ecological and economic development. Using satellite remote sensing data and vegetation cover data, the result indicates the ecological and economic development becomes better and better in Deqing. At last, here are some remarks. China has continuously made great efforts for the implementation of the UN 2030 agenda, such as emphasizing the disaster prevention and resilience in the national spatial planning. As we all know, timely and multi-source data and innovative technologies are needed to measure the SDGs, including satellite image, administrative data, GIS technologies, and softwares, such as SuperMap, the geospatial intelligent software. I think SuperMap is your intelligent choice. Thank you.